Welcome everyone to this week's IPLD Sync meeting. It's November the 2nd, 2020. And as every week, we go over the stuff that we've done in the last week and then over the stuff that we planned for next week and discuss open agenda items. I start with myself. So the kind of the big news and the big relief is that finally Rust multi-hash 0.12 is released. This is the thing that contains the tiny multi-hash stuff, which was a fork of multi-hash something like a few months ago. So now you can really use the Rust multi-hash as a replacement for tiny multi-hash in case you have used it. And it's now no standard compatible, which means for those who are not that familiar with Rust, means that you can use it on systems which don't have an allocator, and so it doesn't do any allocations on the heap for the multi-hash stuff. But there's obviously some functionality where you want to have support for this. So for example, if you want to get it into a proper vector or so on, but it's just an option to do. So that's pretty cool. And then the other stuff on the IPLD world I did was an exploration report about extending the schema maps with more advanced list pair representation. It's kind of related to the string discussions, but it's also a nice kind of like in a separate way. And yeah, I have even more thoughts about this kind of thing, but I still have to write it down or think about it more. But I think this one, like this really is interesting, I think, because it also gives kind of like a different view on like a separation between schemas and data models and how they relate and so on. So I think it's a like, in case you are you are flooded by all the string whatever discussion and don't want to read it all, I think this one certainly is even outside the discussion worth a read. So if you haven't read any of the other stuff that's independent, and have a look. It's the short version is you can build like higher level things with the basic data model in the schemas. I think that's all I did last week. So next on my list is Danielle.
Cool. So my notes this week are quite a lot more verbose because I thought, it's good for myself to keep notes of what I've been doing, but also historically, if I want to look at the notes in the future. So essentially, I did finish the Go multi-codec new implementation with an external contributor last week, but I hadn't actually pushed it to the main repo until now. So now I've unarchived the repo. There's a pull request to delete all the existing code and add the new implementation. It code generates all the codes as Go constants. Initially, we said untyped constants, but now they do have a codec type, which might need to be called code. I'm not sure. Input welcome. But the whole point of having a named type is so that we can have methods like string, which I think is nice, because otherwise they're just integers and you can't really do much with them unless you have separate functions. We also had a couple of more string calls, mostly with Volker. I know that the topic is a little overdone, but at least for me, it was useful to get up to speed because I wasn't. I also got introduced to Andrew's ecosystem dashboard. So I think the point here is that right now we have people that maintain repos and packages and so on, but sometimes things do fall through the cracks and get forgotten just because we have so many repos. So I think I'm going to start essentially keeping an eye at least once a week or so on issues and pull requests from external people that we might have forgotten about. So say hasn't had a comment from us in a few days or a few weeks or so on. And also some more hammed work. I added about an hour ago, I added if Eric's code gen PRs get merged, I'll be so happy because my code will get so much better. But I see one of them has already merged, so that's good. But I've been reviewing those. Also, I've been adding some more tests from the point of view of the Go API, because I expect that all the internal details that people wouldn't directly use directly will be covered by the spec compliance tests, which I assume are still a priority for this quarter. And of course, I already offered my help in getting those done because I will be using them. And I also implemented initial support for link loading, nodes referencing other nodes. But it's kind of messy at the moment, so I'm going to post the pull request tomorrow. And the last thing I have is that tomorrow I'm going to be on the Go Time show talking about, it's a podcast, by the way, talking about what features you could remove from Go, which I think is an interesting topic, as opposed to, everybody's talking about adding features. So I've got some ideas like, dot imports or like struct embedding and things like that, which I honestly hate. But if anybody has any ideas, I'll be happy to bring them up tomorrow.
Thanks. Next on my list is Rod.
Put a link in the docs. Okay, so busy, thick week of work. I felt like I was working a bit too late at night and then deep into my weekend just because I was doing that focus thing that, how it goes. You get in the zone and you just bang it out. I think that's Michael's usual mode with weekends. Can't let go of something. And anyway, so I was doing the car to schema thing. I didn't finish it up because there's so much more in this area, but it's at a state that I wanted to get it to for this initial purpose. Like, how far out can we push this thing in utility with minimal work without creating a whole new rabbit hole? So this thing now does this multi-stage thing where you can run it across a car file and it'll just find the common forms in there and describe them with schemas, and then just give you a huge list and stats about how frequently they're encountered. And then you can add in a library of known schemas to it as well and do a run with known schemas, and it'll add them to the mix. And then and so when you add your own schemas, you can start to make common the shapes that are common. Like, for example, in the Filecoin data, the hamped, because it's variable arity, you have these blocks that have between 1 and 32 elements in an array, but it's all the same data structure, but they end up getting described as separate things because it doesn't know that they're the same thing. So once you start describing that with a schema and say, okay, no, this is just an array of elements and it can be potentially any length, then you start to capture all of the variations into one thing. So you build up a library, and then eventually you find no novel schemas in there. And then you've described all of the things, and then you can get stats on where they all appear. So I did that for the Filecoin data. There's a couple of other little neat hacks in there, like because the Filecoin data is so big, it can do things like you run it across the thing with your library, and you say, any novel blocks that you find, put them into another car file over here. And then you can use that to keep on incrementally making your novel car file smaller and smaller. And so it's quicker and quicker to do these iterations to describe schemas. So I can imagine this being an interesting way of doing schema development for existing data, for validating schemas that you've manually written for forms. Like I want to use this now to go back to the Bitcoin data, because I'm in the middle of that Bitcoin spec, and actually verify that the schemas that I've manually written for the Bitcoin shapes actually matches what the variations of the data that I'm spitting out for that. So that's another use case. It's quite nice for. But there are limitations because this is looking at blocks without context. This is coming back to that whole context discussion that we keep on having, which is fascinating. And I do find this bit fascinating, the limits of context and what context you need. We're encountering blocks context-free. It's just a block with a CID. So yes, you can describe the shape and you can match it to schemas. And so far, there's no clear, as far as I can find, maybe Will could think of something off the top of his head. There's nothing in the Filecoin schemas that conflicts, obviously. So there's not like two completely different data structures that encode looking the same. So there's a lot of things with there's a lot of tuples with two elements in them, but in most cases they're either attached to something else or the two elements are switched around in order. So you've got string and bytes, but then you've got bytes and string. And so by accident, we've got all these unique forms that you can encounter within the schemas. And within the blocks and say, you know, this is actually this thing over here. Even though if you switch those elements around, it would be something over the other side. But there's all these data structures that in the middle of things, like particularly the HAMT and the AMT, where if you've got the leaf nodes, then and they're storing inline values, you know what it is. And there's a lot of these, particularly the HAMT, a large number of nodes are leaf nodes because the HAMT doesn't just have a leaf layer. The leaves can be scattered throughout it. But with the AMT, you've got a leaf layer, and then everything above that is intermediates. And that whole space, everything looks the same. And so without context of how did I get to this node, what linked me to it, you can't know what it's hanging off of. So and also if you don't inline the values, if you put CIDs at the end of the leaves in your data structures, then it all looks the same. So I've got schemas that are like, they're called AMT non-leaf or AMT with links. And so you can collect these things, but and so far there's a limited number of things that actually have links at the leaves. A lot of these structures are inline, but if we were to encourage them to link them rather than inline them to save churn, then that problem would exacerbate. So the ideal state is somewhere that you can, like, this is helpful for schema authoring and getting everything pinned down. But to go further with this analysis, you really do need random access to blocks. Like you need these things in a block store where you can actually start querying them and then build up that chain. And that connects to some of the work Michael's been doing with putting this stuff into a data store you can actually retrieve from. And also stuff I think that Will's been doing with the GraphQL stuff, where you're describing these connections. And that I think that's really important work for us, is to figure out the way that context works with these blocks and how we can build that into our tools in a way that is not super expensive. Because, you know, when we're talking about a car file that's 400 gigs and you're wanting to do context, you know, it just becomes out of hand. So so anyway, that's, yeah, interesting work there. Lots of other avenues for going further. I think the Filecoin team would love answers. Right now, I see the Filecoin team pushing ahead with just optimizations that they think are good. Like Stephen's currently expanding the width of the AMT, which everyone thinks is good, but I don't think anyone knows how wide it should be. And there's a whole lot of questions there about the AMT that we don't have answers to. This kind of data should be able to provide answers to. Like, one of the things Michael and I have discussed is fetching out the values from all of these data structures into a separate thing, and even ordering the operations where they have edited in the chain, because this is live data. So if you could pull out all the values and all the mutations, record them, and then play them back against other data structures or variations in the data structures, you could answer all these questions. And you could say, here's the kind of churn if you increase the width to this. Here's the kind of savings you would get if you swapped it out for this other data structure. Like that's high value work that would be good to do at some point soonish. But I'm not right now. As my second item on the list is, I'm backing up to. I really have to close out some of these things I've left open. I've left a trail of open work, and I have to close them out. So the second half of my week, I went back to my car work, and part of that was designing a new block storage API that could potentially be shared in common with other JavaScript block storage systems. So there was just some design work in that, and how can we think about this? How can we extract out some of the, like, using this data store API has just been terrible, because it just puts too much into the format. But this new abstraction that Ghazala helped me get to really pulls it apart into functionality. So you can then address these storage structures just for the particular functionality that you need. So if you need random access, like just to get random blocks, then yeah, you can have that. But if you just need to iterate over it, then you can just load it as an iterator and say, I just want all of the, I want to see what's in there, or even just I want to see all the CIDs. Then that's a separate thing that you can say, here's my car data in whatever form you give it, whether it's as a binary blob or as a stream or whatever. Give me all the CIDs, and then you just get an iterator. So it's pulled it apart into these separate functions, pieces of functionality. The APIs are separate enough that you could load them separately and only get the code paths in your bundle that need that. And along the way with that, I spent half of my week learning how to include TypeScript annotations in my code and in my build step, which was, I've been meaning to really get more of a handle on TypeScript, and I've been doing that the last little while, and that's turned out to be really nice. It sucks a lot less than I thought, and it adds a really nice linting step to the build process. So you've got linting, but then you've got this structural linting, which can it's legitimately finding errors, which is fantastic. So I'm getting some of those benefits of types without going full TypeScript. So it's just plain JavaScript with TypeScript annotations and using TypeScript to describe the API as well. So there's a link in the docs to, for example, the external API TypeScript doc that it's not used as a core part of the code, but it's exported and it's used to validate all the code paths within the whole thing, including tests. So yeah, I'm happy with that, and I'm going to continue doing that. But this car stuff's pretty much done. I just need to get the docs written for it and then published, and then I can tick that one off. So anyway, that's me. Sorry for taking too much time.
Thanks. And next one is Peter.
Right. So actually, I don't know where my week went. Very little things that are important to IPLD. A few points actually tie with what Rod said. If I manage to get Lotus to play ball with a lot of strict embedding, by the way, like without strict embedding, this wouldn't be even possible because I basically need to split one interface into 3 separate ones while still allowing for, without having to change a ton of code. Like this block store interface specifically in Lotus are used in like 350 to 400 sites, and I need to break them apart without having to rewrite the world. So that's not great. But if everything works right, Rod, you will have access to individual blocks from this block store that actually can do, concurrent key source starts with S and ends with 3, which is essentially the only thing that can keep everything that we need at scale right now. Yes, we still need to figure out some way to do non-AWS hosted block stores, but at the scale at which we're going, there is not going to be a possibility to do any of this on a single machine pretty much very soon. Even if we put all of this into IPFS without the DHT provider, just I have this, even at just storing the blocks at the scale, the amount of blocks that we need, we cannot do this on a single IPFS instance anymore because of Badger and other limitations. So it's great that the work is happening, to get our data stores a little bit more performant, but we basically need like a 10 to 100x improvement. And until then, what's going to happen is basically the chain will migrate mostly to S3. And the twist to this is that there should be a way to get Lotus to bootstrap from that as well, provided we have a separate way to feed it what is the current head that we assume is correct. And if somebody wants to walk through the entire chain from Genesis all the way, they can still do that because a block store is just block store. It doesn't matter where you get the stuff from. The hashes will match and will validate. So it's all good. But yeah, that's what I've been trying to do pretty much since Friday, and it's going, but not well enough because like our block store abstraction is so bad. It's not as bad as our dot store abstraction in Golang specifically, but yeah, they're all at some point we need to design things that work with DAGs in mind. Almost nothing we do right now on the storage side has this in place. Like for instance, the simplest thing, being able to do GC. For this, ideally, especially with DAGs, you need to be able to do reference counting. In order to be able to do reference counting, you need to know a block that you just stored, what other links does it have. If you want to do this today, you basically, in the block store, you have to parse every single block and pull the links out, which is crazy. Instead, we could have an interface that just says like, hey, store this block, and those are, by the way, the links that it refers to. And from there on, you don't have to do anything. But because of how our interfaces are built, that's not possible. There are also the things like, that we already talked about, the enumeration of every single block that you have in the store, and also the way the put interfaces work is, batching is weird. So yeah, mini rant there, but we probably need to come up with better ways to do things, because what we have right now just doesn't scale, and we'll probably get plenty of experience with that as well in the Lenses world. And yeah, that's pretty much all I have.
Just for reference, DAGDB has that indexing that you just talked about. DAGDB has its own block store abstraction, and it indexes every time that you write a block. It writes all of the to and from links in that block, so you can always go and check. We use it for an efficient graph synchronization, so that you can tell if you have a full graph or not really easily. But you could also use it for GC. That was one of the intentions of it.
But do you intuit the links yourself, or the API requires you to supply, like, here is a block and here are the links?
No. When you write a block, it looks at the links and then writes those indexes. It's like literally like on put.
Yeah, but does it parse the block itself, or you feed it the links? Who does the parsing? Basically, do you have the file point problem that you have to understand everything that is being written into it, or is just opaque and you just say, here's the block and here are the links that this block refers to separately?
I think it parses them because it works with full block instances, so they already have a cached decode if they've been decoded. So I think it just reads the links out. It doesn't take them. Yeah, it doesn't take them from it, because, like, again, you're writing to and from, so every new block that gets written has the to and from, so you can always look up a block and know all of the blocks that were written as a result, or all the blocks that reference it. Like that's the point of doing to and from, so that you can
Yeah, but in your case, you also have the codec is stable, right? You don't get like random blocks that you don't know how to get the links out of. So there is that. So.
Oh right, yeah, no, that's true. Yeah.
Yeah.
They're all DAG-Seymour because it's a database.
Exactly.
It makes a decision about that. Yeah.
Okay, and next one is Eric.
I've got a lot of exciting stuff this week. So I sat down and I did code. Yay. And Go IPLD Prime CodeGen basically got a ton of new features. Some of them are still in draft form, but they're very exciting. A couple of small things that are ease of use landed for CodeGen. For example, maps and lists got a bunch more typed iterators generated. So if you've been using some of the CodeGen alphas and you thought it felt like there was missing stuff there that would make your code suck less, you were right, and it's there now. So rerun your generation and you should have nicer things. I ran into these while trying to prototype writing some bigger things myself using the schema CodeGen output, and it was just very visible that we needed some more of these methods, so that, like, once you have, in the native type system what you're holding on to, you should be able to traverse over those data structures and continue to know what the native type of the subsequent things is. Previously, a bunch of the iterators ditched that and went to the overly generic node interface, and now there's alternative methods which will keep you with the concrete information, and those are a lot easier to use. They'll probably go faster because the compiler can inline things around them. Autocomplete works, things that are good. There's another PR out that is about rearranging the CodeGen output. So currently the CodeGen spits out a file per type in your schema. this has been terrible to use because, among other things, it means if you do regeneration and you've changed the names of some types, it doesn't go clean up the old files. So now it makes a finite number of files, so you just don't have to worry about that. We might iterate on the exact layout of those files, but basically getting to a finite number improves usability significantly. And so the really big exciting thing is we now have a draft of the schema types that are used in this Go library to understand the schema type system. Those are now re-implemented. They've previously been placeholders where if you wanted to use any of the schema system, you had to use this really janky temporary placeholder set of builder methods instead of like handing schema information in like the IPLD schema format that we worked so hard to make accessible as JSON, etc. Instead of using any of that, you'd have to call these janky special placeholder Golang methods. That is all going in the bin. And now we have a draft of these schema types re-implemented to use the schema codegen to produce types that match the data model. So now you can connect any IPLD codec to those codegen outputs from the schema, and that will match and recognize schema DMT data model trees. And now you can parse those into the fully reified schema system that the rest of this library uses. So we can glue that to codegen. The gluing to codegen part's a little bit draft still, but it's probably going to come out in the next week or two. It's almost there. So this is, even before it's glued to codegen, this is getting really, really cool. So this has tons more tests than the existing stuff. And so now we can take stuff like, I have tests written which have a JSON document of schema, and that can be parsed. It goes into the schema types. This is coming in 2 packages if you're looking at it in Go, by the way. There's one package that's called schema DMT. So again, DMT short for data model tree. Contrast to AST, which is an abstract syntax tree. This is conceptually the same, but there's no syntax attachment because you can choose any IPLD codec, right? So when you process things into the schema DMT, you have matched the schema. My apologies for how self-referential the self-hosted system is. So once you've got that data, you know that it matches the structure of a schema, and then you can parse that into the full type system references. And the difference between these is the one that handles the data model tree, you can only do so many validations on this. You can check that it's the structurally correct information, but also there are some other properties we want, like we should validate that the whole type system is complete, that all types that reference other types actually, it has to be a connected graph. And verifying graph connectivity is a potentially computationally expensive operation, right? So we're not going to let the schema system alone do that. And this second package validates that as it's processing it. So by the time you're holding on to that, all of these things are validated, and then the rest of the Go library uses that fully validated stuff. So tests exist that go from JSON all the way to that fully validated thing. Some of the tests check that that works. Some of the tests check that that doesn't work, and it returns a sane error message. This is now including all of the validation rules, which have never been implemented before. So this is kind of a big deal. And I'm hoping Rod is going to be available to review some of these with me, because I know we've talked about a bunch of these before. So now I finally implemented them. So all of the little validation rules, like an inline union that contains structs as members, it really ought to check at compile time, so to speak, that the inline union discriminant key should not collide with any of the struct field names in their representation form. Things like this. Yep. And so we've had no tooling to validate this before. Now we do. There are, I don't know how many rules there are like this. I should actually count. There are several dozen small rules like this. And these are things where previously, if you wanted to write a schema, you'd have to read the spec real closely and make sure you didn't screw up. And now we're finally getting to having automated tooling to recognize these things. So this is going to be kind of huge. This is still only connected to JSON parsing, but we already have other tools which go from the schema DSL language to JSON. So we are soon going to be able to just connect those with a pipe character in the shell. And And then we will have schema validation tools that can take the full DSL, apply all of the validation rules. And we are very close to ready to do this in a way that we could put in CI or wherever else somebody wants to put this automation. So that's going to be a huge usability unlock for this whole suite of stuff. I'm really excited to get that across very, very soon now. It's not plugged into a CLI yet, but soon.
So when I write the update for the all hands, I should say that our Go code is on DMT.
Your words, not mine.
No, it's DMT enriched.
I've said many times before on the full record that I am bad at naming things. And we have also many times before talked about how we have these structures that are almost like ASTs, but it's not with an S.
Block building better through chemistry.
I'm perfectly willing to just utterly deny everything we're talking about forever. I think it's a great name. So speaking of, no, that's not really naming. I can't make that segue joke. I've also got one more gist on strings. Like Volker mentioned, we're probably all tired of this, but hey, here's a link. This write-up is still largely oriented around the thesis of this data exists. What are we actually going to do about it? We got some new input on this week where Jeremy actually came in and made sure we looked at what IPFS actually does, which is maybe important. And so what actually is done already turns out to be really interesting. So in Cliff Notes, it is possible to use IPFS add with any file name, where any file name means, of course, any sequence of bytes. Not necessarily UTF-8, not necessarily even Unicode at all. So Jeremy tested that, and there's a link to the IPFS web gateway in here also, which is the result of that. And it turns out the DAG-PB codec stores the bytes we give it. So this works. It is interesting to note that the DAG-PB codec documents this as a string. The protobuf spec file says string. But it is clear that in actuality, the support range for this is a full sequence of bytes. It is not limited to Unicode. There's a comment saying
PB literally has no differentiation between strings and bytes.
Yep. So that's fun. The web gateways do largely handle this correctly, with some exceptions that I will note in a moment. So the URLs in links in the web gateways for like directories and stuff, these are fully precise. They lose nothing. They use sequences of escaping for bytes that are non-Unicode. This ends up using %-based escapes that is normal for URLs and can apparently handle this entire range of data. So all of the data and all of the files, if you make whole directory trees like this, are all accessible through the links in the web gateway. This is the general, like anything that's using DAG-PB data directly generally handles things correctly because it gets the raw data, and so it works. So the web gateway is one example of that. The mounting subsystems also work. They will give you back files with their full arbitrary file names. But not everything works. Here's the exception that I mentioned earlier. The DAG-JSON codecs, which do get used in some of the IPFS APIs, are currently, as implemented, lossy. And so we now have this demo that is linked to in the web gateway does exhibit this behavior. There are some cases where when data is being encoded as a string in the DAG-JSON codec, and I know exactly where this bug is. I wrote it myself, and I'm not happy about it. It will sometimes replace those invalid UTF-8 bytes with the /UFFFD escape sequence, or maybe it replaces it with the byte. And so this is lossy. It throws away bytes. So, but this only shows up in some places, and I have not entirely traced how the web gateway reaches this state, but what I can observe at the end of the day is the links are correct where they're using URL escaping and %, but the file names as rendered are not correct, and they're going to render, well, however your browser renders that Unicode byte. So that is, in my opinion, a bug. This sucks. We should fix the DAG.json codex to escape these things and not throw away data.
So one thing that I want to note before we move on, though, is just like, it's pretty impressive that all of this stuff is making it through the gateway. Like all the escaping is actually making it all the way into like their string interpretation. We have talked a lot about doing a pathing spec. And like this makes me like very confident that we should not write a pathing spec and that we should point to the URL path spec, because then we have all the same escaping rules and we're not worried about people like not implementing them in gateways and then all these other like in between layers. So we can just use URL paths and then we can write a spec about how they get interpreted when you're in the data model, how they get interpreted when you're in different libraries. Like that's how we do the interpretation. That's all.
Yep, I'm basically thumbs up to all of that. It's somebody made percent escaping. It's defined. I honestly haven't looked at it any more deeply than this, other than it evidently works.
Well, and there's a parser in every language. Like every language has a parser for URLs and URL paths. Everything that we would ever jam these into in URLs and URL paths is already working. Like let's just use it.
Yep. And yeah, that's all I'll say about that. I think continuing this conversation in the form of figuring out what we're doing with pathing specifications is also a really good way to go forward. So agree. That's it for me.
And it would be really good to get DAG.json sorted. We've got a bunch of points in DAG.json that are not sorted out. I'm using DAG.json more and more in test fixture related things. And it really is a real problem that it's not consistent between languages and not even internally consistent. So I'd like to get that one hammered out fully.
Before I forget it again, I've never written this down before and I really should. I realized that there's another bug with the precision of DAG.json in the process of this. JSON supports UTF-8 bytes just as the bytes, right? So you can have whatever character. And it supports the /u escaping sequences. So our codecs do not preserve the distinction. At least mine sure don't. So we should be increasing the strictness on that as well. We should probably actually, in my opinion, forbid /u escapes in DAG.json because. So more spec work. Yay, yeah. Oh, some of the faces people are making. Yep, I know.
I actually filed an issue about this a few weeks ago. It was essentially about strings in DAG.json. You can encode them in many ways, and there's no consistency. So we should have a rule about that. I can link it in a sec.
Sorry for not seeing that. Yes, you are incredibly correct.
Okay, let's see, I can go next. I think I'm next. So, so last week, after being put on the async generator path as the way to solve all my complexity on error handling, I ended up abandoning it, working with Michael. It turns out that the GraphSync protocol is a bit too complex to kind of fit into the iterator or iterator generator paradigm. We tried, but it just didn't quite. It wasn't converging. So switched back to kind of the old school way and been working on that. So adding in validation error handling for the requester logic. So that is my update.
To be clear, the way that the protocol works is that there's two streams, one for control and one for the blocks. And because of the way that it's designed, you can't actually implement effective flow control. Like you can't actually do a generator over it, and you can't actually like map the right pauses and resumes in that structure. Because it wasn't really designed to think about flow control. Like you can't even pause from the client, which is like crazy. And because it very much just looks like bitswap in a lot of ways. And bitswap doesn't have this problem because you always request a block. So there's no worry about flow control. But in a point-to-point protocol, this is actually like really important. And this seems to be like an actual like real problem with the design of GraphSync in general that I don't think that we're going to be able to overcome without a new protocol.
Yes, and I'm actually eager to write a new protocol that's far simpler but anyway, that's after this one.
Yeah, well, actually, we were throwing around some ideas about a protocol, and then I had a conversation with Jeremy, and Jeremy said that his original design for GraphSync sounded just like what we were talking about. So I think it'll be well received by at least one person.
Next one is Michael.
Okay, so a lot of what I did last week was get the reviews ready for a pre-calibration call. But other than that, what else did I do? Oh, did some more migration to DagDB to the multi-format stuff. I have to say, I really do like these new primitives. They're like a lot nicer to work with. All the code's getting cleaned up. It's really, really nice. Then over the weekend, I couldn't get this thing that Makola figured out of my head for the sorted trees. And I started to think, like, what is the simplest possible application of this technique? And what I realized that it looks like it's just a sorted set of CIDs. So not a map, because like all you need are things that are ordered by some ordering, and then you need something that is hashes to do this, right? So you just make the key and the value of the hash, or the CID at least. You order them by binary sort order, and then you use the last byte. If it's 0, you just chunk on that. So you don't have to implement like a floating hash algorithm or anything. You just like rely on the randomness from the hash. And I really just wanted to implement it so that I could like see how it works in practice and see how you would implement it. And then to start to sort of look at some of the performance dimensions of the structure. Having something that is this simple and predictable will allow us to like really kind of tweak the performance dimensions and see what that produces in terms of different block structures. With, you know, once we start to add in like, you know, a floating fingerprint, then it's going to get really complicated. Like this whole thing is going to get much more complicated, and it's going to be much harder to predict a lot of this behavior. So I did that. Once I did that, a conversation that I had with Jeremy was stuck in my head where we were talking about these block storage problems, and I was relaying some of what me and Volker had talked about, and he even said, I think outright, like, it seems like the right solution to this problem is an append-only B tree, like a single file database that's just append only. And I was like, yeah. And then once I implemented this tree, I was like, oh, you could totally use this to implement an append only B tree or an append only tree. So I started to design that and worked it out as a database file format. So this is really cool. I've started to implement it, and there's a pretty detailed spec on the design right now. It's called CADB, Content Address Database. But effectively, it's a database that's just a single file. All of the keys have to be hash digests, and the values obviously are binary blobs. It doesn't do any of its own validation, so you have to make sure that you're giving it like good hashes and everything, and that the block data matches. The storage interface doesn't do that for you. But basically, you just use that same technique, and then every time that you write a new entry, you rewrite the leaves that you've adjusted and blah blah blah, like typical kind of B+ tree stuff. And yeah, I'm pretty sure that this will be like the fastest way that we can write this stuff to disk in a maintained, ordered, balanced index over time. We'll have to see what the reads look like, because the depth can get kind of big when you're doing the tree like this. The thing is, though, the leaves are a pretty predictable size once you know the average hash digest size. So if you look at the depth of the tree and the average hash digest, you can actually compute how much of an LRU you would need to keep the whole top of the tree in memory. So what you can do is you can just cache the reads of all the leaves and keep like most of the tree in memory. So I think that you can actually like get really fast read performance even if the tree gets really deep, because you can just keep the whole thing in memory, and you don't have to like you don't have to memmap a file, or you don't have to like be proactively ejecting things from the cache. You can literally just let an LRU let stuff fall out because the top of the tree you're going to access more. So anyway, that's really cool. I'm working on implementing that. If it works and if it's performant, then I'll probably pull Rod in after you finish all of your dangling tasks and work on a more unified spec and hardening the implementation. And then eventually, I'd like a new version of the car file format that just uses this as the block storage. And then we take the other stuff from a car file, like the header and the roots, and stick that somewhere. Because then like we would, if we started using this as the car file format, then we would like instantly get index CID access to everything, right? And when you compact these, they're deterministic. So we still have a deterministic hash over a compacted store. And now as we ship around car files, like you don't actually have to wait to load them. You can just like start the database on them, right? And it'll just work. It's kind of nice. Like there's a lot of really, really nice properties to this format if we lock it down. So yeah, that's what I've been kind of poking at on the research end.
Thanks. So this time I scroll up to the agenda. I don't see any agenda items, but is there anything anyone wants to talk about? Yeah, Peter?
Yeah, I want to add to what Michael said. If you guys are actually looking for good caching performance, I would recommend splitting basically having two files, having the index entirely separate from the data, which is pretty terrible as far as moving it around, but it's the most ideal thing for the VFS to actually keep the right piece of bytes in memory at all times.
The thing is, like,
and being able to leverage what was it called? Not pre-read, but prefetch, disk prefetch.
I don't know. I mean, I'll have to see. Like, if we keep the nodes in memory, it's not going to be much different. And like, the problem with having two files is that you no longer have the nice transactional guarantee. So like I can write the nice thing about this append-only file format is that like the page file is always written as an atomic write. So the file's never in a state that's unreadable or corrupted as long as you ensure these atomic writes. So you just do a bunch of write Vs for the page file. And then the last thing in the page file is actually the position and length of the current root. But if you have two files, then you're like, you don't know if you're in a transactional state or not of updating something. So you can't like take a live database or block store and just copy the file out, which would be really nice, like to just copy the block store out of your Lotus node without shutting it down. Like this is like what people do with CouchDB, actually. It's really, really nice. It's one of my favorite things about that database.
Does it matter whether there are two files or not? Because whether you write your closure in the second file or not is immaterial.
The disk, there's no such thing as a syscall guarantee that two writes to two separate FDs happen at the same time. So there's just like there's no way to ensure that you're in the same transactional state between the two.
Yeah, that's fair.
Yeah, at the file system layer at least. Yeah, and but also like I mean, so you have to keep them in a sorted tree anyway in order to update them. So like in the database. So that's why it's like not actual, like you don't need a separate index because you already have a sorted structure, like to do the lookups in, right? Like I don't think that there's actually like much that we would get out of an index in a separate file.
I think also like one advantage is if you to put the index into a separate file, because like the index really is like a secondary index in this case. So the actual data is in the file and the index is like a secondary index in the sense of it doesn't contain any data that is not in the file. So you can just throw it away. So you can always recreate the index. And if it's a separate file, you can just do it. Or you just
but you have to scan the whole file.
Yeah.
To recreate the index. Yeah, I mean, like, yeah, I don't think that's a great option.
You can also copy just the index.
I mean, honestly,
but that's what the carbs thing is doing right now, right?
Yeah. But that is because the structure of the file format for the car file doesn't keep things in order because it isn't actually a database, right? Like that's why it's a secondary index. Now, we eventually will probably end up with a secondary file anyway, because for Peter's thing of maintaining the link indexes for the GC, that is not going to be in the same file. So that would still need to be a separate file and probably exported separately. But you could do like a nice,
Yeah, it's also for us, the advantage of a second file is also that you sometimes need different guarantees. So for example, for the main file, you really want to make sure that the fsync really happen and so on. But basically, if your index gets corrupt, I mean, it shouldn't get corrupt, but if it does, it's not a big deal because you could always regenerate it. So you might end up with basically systems where you put the index file, which is like faster and might have more errors or something, and you don't get it much.
I know, but like, here's the thing. Like, I understand why you would want to have a secondary index over a structure that wasn't well sorted, but like this structure is actually like a well sorted structure in the file format. So I don't really see what like the index is only saving you like some branch reads effectively.
No, but I mean, your append stuff is not sorted. Like your append.
No, but the appends are writing references to a tree that is sorted. Like that's not how car files work, right? Like car files are just like atomic block writes. So there's like there's no way to index them without scanning it. Whereas like this on this structure, like every time that you so okay, you have a database, you do a set of writes, those manipulate parts of the tree. You rewrite all the branches that changed and any new block data, and then you rewrite the head pointer for all of those branches. So the last head pointer to the root is to the root of a sorted tree structure for updating the actual index. So you have an index, you have a well-sorted structure for seeking into the file and like finding what you need. So the secondary index like doesn't really save you much, especially once things get a little bit hot.
No.
Are you essentially rewriting the entire index every time at the end of the file, essentially?
The parts that change, right?
The parts that change, yeah.
Yeah, but if you only write the parts that change, then your thing is no longer sorted because you have stuff here, you have stuff at the beginning of the file, you have stuff all over the place.
The tree is this. So hold on. The tree shape is the same regardless of compaction. Where they are in the disk changes if you compact. So like this is what we're talking about. Like throughout that whole structure, throughout that whole file format, a bunch of places don't have data in them, but that doesn't actually impact the performance of the tree because the tree is still the same shape regardless of whether you compact it or not. Because as you change it, it's rebalancing with the hash.
I guess the point that I would say is your reads, especially on a cold start, you're doing log n reads on down that tree to get to your data item. And all of those are now happening out of your file. So that's log n random seeks. If you have your index in a separate file, you can put it fully in your SSD and you can have those reads through that much smaller index structure happen faster, even in cold cases, and only do a single read on your IO disk to retrieve the item.
I mean, like that makes sense if you're exporting a bunch of data and then reloading it in to get something fast up and running, right? But it doesn't make a lot of sense at all if you're maintaining that index as part of the database, right? Because you have to rewrite the entire fucking index every time.
Just the parts that change in the same way, right? You could do your same structure of a tree thing where you're rewriting the parts of the metadata that's changing in the secondary file that's on your SSD.
Oh yeah, well the secondary index.
And your IO one is just a log file system that's still just appending the blocks as they get written.
What I meant with secondary index, like what I was saying is like basically what you call index is like a secondary index. So I'm not talking about having another secondary index, but basically what you call index is like a secondary index from the properties. Like your index doesn't contain primary data. The primary data is the append only thing in the leaves.
Mm-hmm.
So basically, so for my definition, a secondary index is an index which can always be recreated from the original data. A primary index is an index which contains data which, if you lose it, you don't have a chance to get it. And this is what I meant about that your a secondary index, and therefore you could, as Will said, you could potentially, even in your case, you could just put this thing into a separate file if you would want to.
Yeah, I mean, the separate file index has to be loaded entirely into memory, right? That's how you use that IDX, right? Currently, the car file?
No, it doesn't need to. It can mmap because it basically, I mean, to generate it does, but for reads, it doesn't need to. So when it's doing the lookups after generation, it's a B tree, and it's doing the search, and that's not an mmap backed price of region where it doesn't all need to be in memory at once. There is a file. It knows that that's the sorted list of SIDs and the offsets into the main data file that those are. It does log n reads into that index file to learn where the item is, and then it does one read into the car file to get the item.
Yeah, that tree structure is, like that is effectively the exact same data structure that I'm already writing to the append-only file. It's a
Except
sorted,
it's all in one compact thing because I'm doing a single scan over it. But you could, and it is, because it's just that implicit record array that it's using as its sorted list of those SIDs, what you can do is you can have a tree and you can have the branches and you can write a new root and maintain your metadata in an append-only way as well, like you're imagining doing on your car, as your way of better maintainability, right? Without having to reload everything.
Well, like, so the random access is just like not an issue on SSDs as much. So like, I'm not like, it's not actually a big deal.
It's still pulling in a larger block on each read. So there, if you can get locality, that's sometimes nice. And that's what you would get with your, I think as a byproduct of your updates, is that like your root and the things close to the root often will be all changing, at least a path of them. And you'll end up with those in the same block that's getting pulled back into memory. So that's worth thinking about maybe, but I suspect you're right that it really doesn't matter that much. That the things near the root are just all going to end up in memory anyway, and it's the things close to the leaves that are being actual reads.
Yeah. I mean, like the tree that you're talking about is very much like the tree that I'm talking about. It's just that my tree has the actual block data written alongside of it. All right, and so it's like all in the same file. I mean, one thing that I do though, like. I keep separate file descriptors open for reading and writing, just so that the position on the reader is always the same. So that actually is a lot nicer and does speed things up quite a bit. But I don't like the access is not usually a huge deal. But I don't know. I'll benchmark it and see what it looks like.
Just don't micro benchmark. Benchmark like a real person.
It's talking to it's all disk operations. There is no micro benchmark. Like,
yeah. The people investigating the block stores want to work with you.
All right. Is there anything else?
I can say I've got a PR that generates a GraphQL schema out of an IPLD prime schema. I'm starting to work through auto-generating GraphQL server from that as well, so that you can serve out of your IPLD data store and deal with queries that people come in that are in an IPLD format. So basically that's additional codegen that follows the existing Golang codegen. And figuring out how those two connect, but that's the current thing I'm working on.
That's really cool.
Yeah.
Cool. We are out of time, so then I close the meeting, and so thanks everyone for attending, and see you all again next week.